Okay, are we on here? There we go. 2.4 Algebraic Reasoning. Some of the stuff is going to be review and some of it's going to be somewhat new. So first stuff that you're going to have to refer to, you do not have to put this in your notes. Do not have to put this in your notes, but you're going to need to refer to this material. The algebraic properties of equality on page 92. You do not have to put this in your notes. Distributive property, you've seen that before. The reflexive property, symmetric property, and transitive properties of equality on page 94. This stuff you need to put in your notes. Page 94, this stuff you need to put in your notes. Reflexive property, as you look up here, the left side of the equation is the exact same as the right side of the equation. Doesn't matter if it's a real number, segment lengths, or angle measures, or if a dog barks in the background. Okay? Symmetric property, if A equals B, then B equals A. It's just a converse. You have an if, then. So the if stuff and the then stuff, all you're doing is switching the order. Doesn't matter if it's the real numbers, segment lengths, or angle measures. Okay? You just switch the order. Okay? And transitive property states if A equals B and B equals C, then A equals B. If A equals that stuff, and if that same stuff equals C, then why go to the intermediary? You can go here straight to the end. Same thing. Here's another example for segment lengths. Here's another example using angle measures. Okay. This stuff you need to put in your notes. Now this stuff, just as a reminder, in the upper right corner of your homework, name, date, period, teacher. So your first and last name, today's date, the period, whether it's period 1, 2, 3, 4, 5, or 6, the name of your teacher. Okay, and then you have your assignment right here. Okay, so we have, move that over there, and put that over there. Okay, here's question number 9. Question number 9. So algebraically, we're going to solve this. From here, we have to solve the problem. And in this case, here's an equal sign, which means it's an equation. When it has an equal sign, it's an equation. And we're going to, where did I have my, I'll show you the difference. 2x plus 19, 7x minus 3, and 2x minus 18. This is an equation. This is an expression. This is an expression because there's no equal sign. This has an equal sign, therefore it's called an equation. Okay, and PEMDAS, please excuse my dear Aunt Sylvia. Now, some of your teachers may have called this G for grouping symbols instead of PEM, P for parentheses, PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. When you're simplifying an expression, when there's no equal sign, you start from here and you go down this way. However, when you have an equal sign, when it's an equation, you start this way and you work up. When you have an equal sign, okay, you start here and work up. Okay, keep that in mind. So we have to solve this. This stuff you've done before in algebra. What's the variable? It's x. Here's the equal sign. On which side is the variable? The variable's on that side. X is on the left side of the equal sign. Okay, so eventually what we want to do is keep x on this side and everything else needs to get on the other side of the equation. So first thing, according to PEMDAS, okay, can we add or subtract? No. Can we multiply or divide? Yes. So this 5 times this stuff in the parentheses. The opposite of multiplying is dividing. So we divide both sides by 5. And we end up with this. Okay. Next step. Again, PEMDAS. We're going this way. Can we multiply or divide anything else? No. All right. Can we, any exponents? No. Any parentheses? No. Okay, so now we've done through it once. Go back and start again. Add or subtract? Yes. Okay. We do add or subtraction first, then we see if we can multiply or divide. This is the order of operations. You always have to do it in that same order of operations. If you do it in the same order of operations, that means everyone gets the same correct answer. If you don't do this, you could use any version you want and any order you want, which means you're going to get a lot of different answers. This is used order of operations so everyone gets the same answer, the same correct answer. So we can add 20 to both sides, and we get this. Now, any more addition, subtraction? No. Can we multiply or divide? Yes. Now, can we 3 times x, the opposite of multiplying by 3 is dividing by 3. So we'll divide both sides by 3, and you end up with this, and there's your answer. You can always go back and check your work. Now, this stuff you've done before, and hopefully you show your work. If you show your work, this stuff will be a lot easier because we know I have to go back through here and write the property that justifies the step. Okay? What's the property that justifies the step? If you look back on those notes on, 92 and 94, this right here, as long as we do it to both sides, we divided both sides by 5, therefore it's, we always start with what you're given. We're given this stuff, so it's a given. This information we're given, okay? And then we divide both sides by 5, so that is why this is the division property of equality. Again, these notes are back here on page 92, 93, and page 94. Over here, we added 20 to both sides. That's why that's the addition property of equality. Okay? Hey, we divided both sides by 3. If you divide both sides, I wonder what that one's going to be. Division property of equality. Okay? There you go. That's it. You're done for question number 9. So you have to do this column. This is where this is the statements where you show your work. On this second column here, these are the reasons that support those statements. So 1 column, 2 columns. It's called a 2-column proof. Why is it called a 2-column proof? Because there's 2 columns. 1, 2 columns. Boom! Okay, next, right here, we start with that question number 12. What would we put over here? Let me give you a hint. What are you going to put over here? Given. This is what you're given. So, using PEMDAS, what are you going to do first? Well, first of all, here's the equal sign. What's the variable? X. X on both sides. We have to get X on one side or another. I'm going to choose to get X on this side because there's a whole bunch of junk over here already. I just want to, there's not much stuff over on this side X. I'm going to get the X's over here. Okay, so eventually we got to get all the X's over here. Anything that's not an X will have to go over there. So what are we going to do first? So in this case, PEMDAS, can we add or subtract? So in this case, from just red color, there's my red color. This is what we did. Right there. This is on page 93, I think. Page 93. Okay. Going from this step to this step, we used distributive property. Okay. How far are we off to? I think we're way off. There we are. Right there. Okay. Excuse me. Next step. Doink. Kadoink. I combine these terms, and that is combining like terms. Combining like a terms. Combining like a terms. Okay. Next step, we add 6x to both sides to get this. I wonder what the next step is. Since you add the same thing to both sides, it's addition property of equality. Then, again, using PEMDAS, we're going to have to get this negative 12 to the other side. So we divide both sides by negative 12 to get that. And when you divide both sides by the same thing, you get division property of equality, and you get this. Now, you could write it this way. I don't care. Some teachers say they want to see it that way. I personally don't care which version you use, but you need to ask your teacher which version they find acceptable. Either one's fine for me. Okay, and you just finish your 2-column proof for this algebra problem. Okay, when you get to question number 21, it says solve the equation for the given variable. So here's an equation, then you have a semicolon, and then you have a variable. So that means we have to take this equation and solve for the value of that thing, an R. R. There's an R. So I want R in the numerator in the top, which it is. Anything that's not an R, you get on the other side of the equation. So how do you get this stuff to the other side of the equation? We're going to divide both sides by 2 pi. Not Tupac, because he's not around. It's 2 pi. Okay? When you divide both sides by 2 pi, you get this. Okay? You can write it this way, or you may write it that way. I don't particularly care. Either one's fine. So how do we go from what we started with here, that was given to us? How do we get from there to there? We divided both sides by 2 pi, so it's division property of equality. Okay? Next one, number 25. Number 25. Righty then. Shaboom. 25. Number 25 states, name the property of equality that the statement illustrates. So you may need to look at look in your notes on page 92 or 93 or 94. So if this junk, then that junk. Okay, I'm going to write it differently. I'm going to write the if stuff first. Then I'm going to write that stuff below. Visually, this is a little easier because we're starting with this. That's given to us. Okay, it's given. How do you go from here to here? What do we do to both sides? Looks like we multiply both sides by 3. I wonder what we put over here. Multiplication property of equality, because we multiply both sides by 3. Boom. Done. How do you go from here to here? That's how it's done. Okay. Question 33. If this stuff, then that stuff. I'm going to put the if stuff first, and then if stuff first, and then down below that, put the then. First I write the if stuff, then I'm going to take this stuff down below. Okay, how do we get this? It's given. How do you go from here to here? AB is there, 20 is there. The only thing different is you added CD to both sides of the equation. When you add CD to both sides of the equation, I wonder what you're going to do next. It's the addition property of equality. Sweet. Sweet as your mama. Boom, boom, boom. There you go. This is the stuff you're going to do for 2.4. Okay? That was it. Good luck, guys. Bye.